the worksheet there.
All right. Well, I think okay, maybe yeah.
So A1 here, I'm just rewriting it. 5x plus 4 equals minus 3 times 2x plus 1 plus 4x.
Okay.
And this is a linear equation. And I know
Yeah.
that because x is to the power of 1 everywhere.
Okay.
Okay. So the way we solve a linear equation is we want to get x by itself.
Okay.
And before we can do that, though, we need to distribute this -3 to both of these on the right. Okay, so that's -6x minus 3. Bring the 4x down. And on the left side, you just bring the other terms down also. So this is the distributive property, or we just say distribute.
Okay.
Okay. Now on the right side here, you can actually combine -6x and positive 4x. -6x and positive 4x. What do those combine to? -6x plus 4x.
It combines to it combines to 2.
-2, because the 6 is more negative than the 4. -3. Okay.
Yeah.
Okay. Now, generally you move terms left. Okay, especially x terms. So to move this -2x, we're going to add 2x. You undo subtraction with addition.
Okay.
So what is 5x plus 2x? Can you tell me that?
5x plus 2x.
Yes.
Five x plus 2x. All right. 5x plus 2x is 7.
7x plus 4 equals -3.
Yeah.
Okay, and this right here is a 2-step equation. That means there's 2 math steps we're going to use to solve it. We have to first undo addition by 4. How do you undo addition?
The subtraction.
I'm going to subtract 4 from both sides.
Yeah.
Okay, we're almost there. Okay, you divide both sides by 7 because the 7 is multiplying x. So x equals -1.
Okay. Do I have to write it down?
You should write all this down. Everything from this
Okay.
first line you should write down. So
Okay. Okay, let me just write that down. Okay.
all right, we're going to look at another linear
So
equation.
this one is the solution is x equals -1, right?
Yes.
Okay.
All right, so we're going to look at B2 next 2/7 x minus 7 equals 16/7 x minus 2x plus 4. This is linear. It's linear because x is to the power of 1 everywhere. But it's different
Okay.
than the last one. This one's got fractions in it. And,
Yeah.
and fractions are very unpleasant, aren't they?
Fractions are very pleasant.
Yes. Yeah.
Wait, what of wait, are we in B1?
Nope. What do I have circled over here?
B2.
B2.
Wait, so we're doing random problems, right?
No, we're doing them in order of things that are easiest to understand. So the first problem I said was a linear equation. X is to the power of 1, x is to the power of 1, x is to the power of 1. And B2 is also a linear equation.
Okay.
The reason we're doing it in this order is that it's always good to do something like something you've already done to understand.
Okay.
Let me know when you're ready to proceed through this problem.
Let's just proceed.
Okay, what is the fraction? What is in the denominator of both of these fractions?
7.
7. Since it's the same, we can multiply everything by 7. Okay, but that means we're literally multiplying everything, and I'm gonna try to highlight. Well, I don't know if that's the right thing here. I guess I'm gonna circle it in green. We're multiplying this by 7. The next thing there in blue by and green by 7. This by 7. This by 7, and this by 7. All of those are being multiplied by 7.
Okay.
Okay, so I'm going to show this step by step. So the first one is 2/7x. You see how I just copied that down, but we're multiplying it by 7. Okay, what does that become? How does that help? Do you see that the 7s cancel?
Now I see the 7's canceled. Yeah.
There's a 7, so you're left with just 2x. Okay.
Okay.
Now the next one we're gonna do is this green. Okay, we're gonna bring down the minus 7 and we're gonna multiply by 7. What is 7 times 7?
7 times 7, 49.
49. Very good. Equals. Now we take this 16/7 and we also multiply it by 7. And again,
Okay.
do you see how the fractions have to cancel? The top cancels the bottom, and you're left with 16x.
Yeah.
Then we take this minus 2x and we multiply by 7. So you take this 7 and go with the 2 minus 14x.
Minus 14x?
Yes. Are you able to see my screen?
Yeah, minus 14x. Yeah.
Okay.
How and so for minus 14x, you have to multiply 7 times 2.
That's right. And then the last one here, plus 4, we're also multiplying by 7, which is 28.
28. Okay. So 28 and then let me just okay. 28 and then you divide by 28.
Well, no, you have to combine like terms. We're going to combine these right here.
16 and 14.
Yes.
That right there is 2.
2x plus 28.
Yeah, 2x plus 28. So that's the answer?
No, that's not the answer. We're working through the problem. We're just at this line. Are you caught up to this line in terms of what you're writing down?
Yeah.
So may I proceed, or do you need time to copy?
Go up again, please.
Okay, it's really important that you copy it as we go. That will help your understanding.
Okay.
Let me know when you're caught up to this line here.
Yeah. Okay. Almost there. I'm just combining them. Okay.
All right, so just like in the previous problem, we're gonna undo positive 2x by subtracting 2x, or undo it with the opposite operation. Okay. So what is 2x minus 2x?
4.
You have 2 of something and you're taking 2 away.
I thought you were just saying it was like a negative where I know it was a 0, but I just don't know if 0 is the right answer because there's a negative. That's why.
Okay. So when you have 2 and you take away 2, 2x minus 2x,
It's 0.
it's 0. Minus 49 equals 28. So if I get rid of this 0, is
X minus
this,
49.
well, no, we just said it was 0.
Yeah, 0 is X.
No, okay, so 0 times x. What is 0 times any number?
0.
0. So we don't have to write it. We can, but we're going to not write it.
Yeah, we'll just write X. Can we just at least write that?
No, that is incorrect. It is not x, it is 0. You had 2 x's and you are taking 2 of them away. There is nothing that remains. So what you're left with is this statement, minus 49 equals 28. And my question to you, Sourish, is this true?
Yes.
Okay, so if this were true,
But true right there, you
Let me-
just have to just combine them.
okay, let me try it differently.
We have to combine them.
Let me try another way here. Is the number on the left the same as the right?
No. It can't. No.
No. Okay, so this means right here, when you get this situation, this means that there is no solution.
Yeah.
Because the numbers are not the same. If they were the same, then we would have another situation, but they are not the same.
Okay. All right. So so we can combine them right now. So no solution, but there's no combining.
There's no combining because see how x is gone? We eliminated x in the previous line and we're left with,
So we can so it's not a solution.
there is no solution.
Okay.
Do you recall what kind of lines have no solution?
Inner parallel.
Parallel lines have no solution.
Okay. I wrote it down.
All right, so we're going to move on to, we're going to go to D2, the system of equations.
Okay. D2, the system of equations.
Yes. Now I thought we did a lesson last time where we actually talked about some of the methods for solving a system of equations. Do you remember any of those?
This is solving the system equations. Maybe we have to use slope instead.
Well, that's if you're going to graph them. Graphing is an option.
Okay. I
do you
think for
remember?
that, we just have to solve systems of graphing. But like for that right there, oh, wait a minute. I think I know what is that for. I think I know what is that for. Yes. Like -4, like for -4, you just multiply 2 times 2, and then something will give you the 4.
Well, I think what you're,
X2 and X2.
so the other methods that what we might have talked about is substitution. And that's kind of what you're talking about right there.
Yeah. Yeah, it's like x minus 2y equals -4, where x minus 2 and x minus 2.
So when you use substitution, you actually want to solve for a variable. Okay, so we're going to look at equation 1. We're going to look at this equation right here, x minus 2y equals -4, and we're going to solve for x. Okay, that means we want to get x alone.
Okay. Get x alone.
Yes.
Okay. All right. Okay.
So do you see how 1x is over here on the left? Like it's almost alone except for this -2y. How do you undo subtraction?
Add.
You add 2y. We're going to add 2y to both sides of the equation. So this becomes x, you just bring it down, x equals 2y minus 4.
2x minus 4. Yes. That's right.
It's x equals 2y minus 4.
X equals 2y minus 4.
Yes.
Okay.
Let me know when you get that down.
Yeah. Okay.
Do you have it all down?
Yeah.
Okay, so what I'm gonna do here is I'm just gonna make a little space here, and I'm gonna rewrite that second equation. That second equation was 3x equals -5y plus 24. That was the second equation that we were given.
Okay.
Okay, and now see how we have x equals up here? We're gonna take this stuff on the right hand side here. I'm gonna highlight it here. We're gonna take all this on the right hand side, okay, and we're gonna put it in for x.
Okay. Okay.
So we're literally gonna physically take all that and put it in for x. So how does that look? Well, in the next line, I'm gonna write 3 parentheses 2y minus 4 instead of x equals -5y plus 24.
Yeah. Okay. All right. So, okay.
So now this is a question that we saw in the previous examples, A1 and B2. This is now a linear equation.
Okay. Let me just write the 2y down.
Okay.
Okay. All right. I wrote it down.
Okay, so on the left here, we're going to distribute the 3 to both of these. So 3 times 2y is 6y, minus 3 times 4 is 12. And then we just rewrite what's on the right-hand side.
Okay. Okay.
Let me double check something here because this is not.
Wait, what happened?
Well, the answer, I'm looking ahead here to the answer and it's not looking good.
Hmm.
Why would your instructor do that to you?
Well, I think he just wants to. Okay, I think what he wants to do is that there's a quiz next week, and I think we have to do it.
Give me just a moment here. I'm going to check the solution of this graphically and see if I can get an answer for why this is so weird. All right, here we go. Let's try that. Wow, there must be a typo in this. Okay, we'll just keep going here. So if we add 5y to both sides,
Yeah.
11y minus 12 equals 24.
Okay. Equals 24.
Yep. Then you add 12 to both sides. So 11y equals 36.
11y equals 36. Okay.
You divide both sides by 11 and y equals 36 divided by 11. And that's what I was looking ahead to. And I'm like, wow, that's not all that nice.
Okay. That is a big problem.
Yeah, so now we've got to actually go back and find x. If you recall, we substituted in for x. We said that x is 2y minus 4. So there's a bit more here. X is 2y minus 4. So we have to take this value for y and put it in for x.
Yeah.
So x is 2 times 36 over 11 minus 4.
2 times 36 over 11. Okay.
When you're multiplying fractions, you multiply the tops and the bottoms. So it's 72 over 11 minus 4 over 1. Now, when you're adding or subtracting fractions, you got to make like denominators. So we're going to multiply the one on the right by 11. So this becomes 72 over 11 minus 44 over 11. And that equals 28 over 11. And that's your x value.
Okay. So y equals 36 and 11 and x equals 28, 11, right?
Yes.
Okay. Okay.
All right, so let me know when you get all that down.
Okay, I wrote it down. I wrote it down.
All right, so we're gonna look at the next question here. I'm gonna check the answer for it first before we proceed, just to see if it's got a nice answer.
Okay.
Okay, this one actually does have a reasonable answer. So let me just rewrite it. It's a little grainy with this. 2x minus 3y equals minus 7. And I'm actually going to write the second equation off to the right here because we're gonna put it in standard form. Okay, so these are systems of equations, and standard form, we didn't do that in the last problem. Standard form is ax plus by equals c. But what that means is the variables are on the left and the numbers on the right. Do you see how the variables are on the left here? 2x minus 3y. On this one over here, the variable, there's a variable on the left, there's also a variable on the right. So we're going to add 5y to both sides to get the variables on the left. So it's 3x plus 5y equals negative 20.
Mm.
Okay, so this is our new system. And this is the one we want to solve.
This is the
And I'm sorry, I didn't even label it. This is B, or I'm sorry, this is D3. We're doing D3 now. It's another system. It's the last system.
Okay. Okay.
All right, so if so we're ready to solve this system, and what we're looking for, we're going to use the method of elimination. I'm sure you've seen this in class. We were kind of doing it last time we met on some systems problems.
Method of elimination.
Yes. So I want you to pay attention to how these right here, minus 3y and positive 5y, do you see how they're opposite in sign?
Yeah. Well, they're the same. Now there's a y. There's a negative y.
They're opposite in sign though. One is negative, one is positive. Do you see that? Whereas 2x is positive and 3x is positive, they're same sign.
Okay.
So what you're gonna want to do here is multiply the first equation, everything in the first equation by 5. Okay. So we're gonna multiply each of these by 5. So what is 2x? What is 2x times 5?
2x times 5?
Yes.
2x times 5 is 10.
10x.
Yeah. 10x.
What is minus 3y times 5?
Minus 3y plus
We're multiplying. We're multiplying. That's what the distributive
minus
property is.
3y times 5.
Yes.
15y, negative 15y.
Negative 15y, good. And then minus 7 times 5, what does that become? Or what is 7 times 5?
Okay, minus 7y, then that equals 22.
No.
Negative 22?
7 times 5.
It's 35.
Yes. So why are you telling me 22?
I thought they were just adding. That's why I just heard that.
Okay, so now we're going to grab the second equation, 3x plus 5y equals minus 20. And this time we're going to multiply by 3. We're going to multiply everything by 3. We're going to multiply 3x by 3. We're going to multiply 5y by 3. And we're going to multiply negative 20 by 3. We're going to multiply every single thing by 3. What is 3x times 3? And I'm asking you, what is 3x times 3?
9.
9 what?
9x.
9x. 5y times 3?
5y times 3. 15y.
Good. And minus 20 times 3?
Minus 20 times 3.
Yes.
Negative 60.
Good. Now, do you have all this written down?
Okay. I'm writing it down. How come 3 times 5 equals 20? It's 15.
Where are you looking?
Here, why? How come it's 20? It's not 20, it's 15.
I'm not sure what you're referring to.
5 times 3 is 15, not 20.
Where I don't see that.
You see right there, over there. Over there. At the left. I mean, right. Right
Okay.
at the second one.
This line right here.
Yeah, it's not 20, it's 15.
What do you mean it's not 15?
Because it's 15, not 20.
Which number? This one down here?
No, right there at the second one. The
Right.
answer negative 23. It's not 20.
Well, it is. The second equation is 3x.
And how come it is? How come it is 20? You should multiply 3 times 5.
We're going back to the original equation here. The original equation is
Okay,
3x
maybe.
equals minus 5y minus 20, and it becomes this.
Okay. Okay, got it down. All right, I got it down.
Okay. So we actually now have the two equations that we can use to solve the system. I'm grabbing the one from the left, and I'm grabbing the one from the right. Again, it's important for you to copy this down as we go. That way, if you have questions, you can ask me as we're doing it.
Okay. Okay.
So now we're just going to add the equations together.
Add the equations together. Okay. So okay, we have to add the equations
Right.
all together into 10 plus 9 is 19, 15 plus 15. It is 0.
Well, it's negative 15 plus 15, which is why it is 0.
Yeah. It's 0.
So we have,
and then negative 35, negative 60 is negative 95.
yes.
Okay.
So now we divide both sides by 19. And we find that x is minus 5.
Okay. Okay. And x equals 5. Okay. All right, let's proceed.
Okay. So now that we have x, we need to find y. So to find y, we go back to one of the original equations. And for ease, we'll go with, let's go with the, well, they're both sort of horrible. Let's go with the first equation. So 2x minus 3y equals minus 7. So we're going to take this x value, this minus 5, and we're going to put it in for x. So 2 times minus 5 minus 3y equals minus 7. So go ahead and let me know when you get caught up to there, and we'll continue.
Okay. All right.
Are you caught up to this line?
Yeah,
Okay, so
it was already, yeah, it was already in. I already wrote it. Oh, what?
2 times minus 5 is minus 10, minus 3y.
Yeah.
Okay, and now we're going to add 10 to both sides. So this becomes minus 3y equals 3. Divide both sides by -3, and y equals -1. So your solution is x equals -5, y equals -1.
Minus one. Okay, yeah. Yeah, it's already in. I just already put it in.
Okay,
Yeah.
so we're going to move to solving quadratics next. How does that sound?
Well, fine.
We don't really have a choice, but we'll do the best we can here.
I know.
All right, so we're looking at, I'm going to do B3 next, B3. Have you ever played Battleship, the game Battleship before?
Battleship. Oh, yeah. I used to play that.
Battleship is kind of like this. You, as you know, you tell your opponent, you say, hey, do you have something at B3? And he says yes or no.
Yeah, okay. Okay.
Right. Here we're gonna factor to solve. Okay, so this is a totally new approach. We're going to factor to solve. Notice everything is on the left-hand side of the equation. Okay, and when it's in this format, you look at this last number, you look at minus 24, and you write all the pairs that multiply to minus 24. So for example, -1 times 24 gets you back to minus 24.
Okay.
-2 and 12 gets you also back there. -3 and 8, 3 and -8, -4 and 6, 4 and -6. Okay, and then what you have to do, Sourish, is you have to go ahead off to the side here.
Yeah, it all for -24, it's like where to find a number that equals to 24.
You have to add each of these. You have to add each of these pairs, and you have to let me know which one adds up to -5. So I've written down all this operations on here. One of these pairs will add up to -5, which is what we were trying to start with, what we were trying to get to. So I want you to look at this list here on the right, and which one adds up to -5.
Which adds to -5?
Yes.
I would say 1 and 4.
But they're not on this list over here on the left. Let's try this again. I'm going to go ahead and delete all this. Okay. And we're trying to do this a little slower, make it clear here. Okay. So -1 and 24. Do you agree that these multiply to -24?
Yeah.
What is -1 plus 24?
-1 plus 24. -23.
-23. Okay. 1 and -24. What is 1 plus -24?
-23. -23.
Okay, it's -23, and actually the first one is +23. So now it's -2 and 12. What is -2 plus 12?
Wait. How come it's positive 23?
Well, it's -1 plus 24. 24 is further away than -1. So the next one here is 10 2 and negative 12. 2 plus negative 12 is negative 10. Okay, and this continues here. I'm just gonna have to, we're running out of time here. So the correct answer here is that it is 3 and negative 8. 3 plus negative 8 is negative 5. And those are the numbers you write here. X plus 3, X minus 8 equals 0.
Okay.
So when you find those, you set X plus 3 equal to 0, X minus 8 equal to 0. And then you solve each of these. You subtract 3 from both sides, X equals minus 3. Add 8 to both sides, X equals positive 8. So go ahead and get all this down. Mostly it's the stuff to the left here. That you need to get.
Okay.
All right, when you get this down, go ahead and let your dad know we are all done for today.
Okay, let me just hold on a minute. Hold on a minute. Oh, come on. Just let me just write this down just for just one. Okay, Dad. Okay, thank you, Matthew.
You're welcome.
Hello, hi.
Hi, Dr. So good lesson today with your son. The stuff we're working on is a synthesis of a lot of concepts. And, he's doing fine following along with me, but the real challenge here for him is to be able to dissect that assignment on his own. I mean, he's given, I would say, 5 different types of problems, and he really would struggle to differentiate between them. So this is really a tough assignment for him. I would, he's capable of doing this, but it just is tough. It's really tough for him with some of the things you've told me. So if we have time, I would like to continue here with this in our next lesson, obviously. But this is really the toughest stuff when he is given like 2 different concepts and he has to choose between 2 different ways of thinking to solve the problem.
Oh, okay. Okay, I think, he needs to practice,
Yeah, if he's got time, I would recommend that he work through all the problems that we did today. We did them in a way that we did the 2 linear questions. We did those right after each other. He should try those again on his own. Then we did 2 system of equation questions together. He should try those on his own. And if he's got questions, he can obviously look at the notes and compare to them. So if that's possible, Sourish, please give those a try, either maybe after you've had a snack or something.
Yeah, you should try Sourish, please. You have
Alright.
to review that. Okay. All right. It's very important. You keep practicing and reviewing.
Okay.
All right.
All right. Thank you, Matthew.
Yeah.
You're welcome. So I'll see you guys on Thursday at 7 o'clock.
Yeah. Okay.
Okay. Have a great night. Bye now.
Bye. So you need to practice.